Hello class, welcome to our lesson today. We're going to be looking at section 10.2, dealing with the basics of probability. In our previous class, we dealt with developing kind of our own games and dealing with spinners and dealing with probabilities of that nature. Today we're going to be looking at some more ideas about probabilities, so let's go ahead and get started. The first thing that we're going to look at here today is dealing with just solving inequalities and prime factorization. So for this first one, it's just solve the inequality. So it would just be like a two-step equation, just with an inequality instead. So add 5 to both sides. I get 4x is greater than 37 and divide by 4. And I get x is greater than 9.25. Remember, this should be an open circle at 9.25. Since it's greater than, the arrow is going to the right side. Remember, if it's an equal to underneath, it should be a closed circle versus this one being an open circle. A reminder, prime factorization is the tree thing that many of you are used to. Remember, this tree idea is to get to prime numbers, and the whole goal of this is to figure out what prime numbers multiply to equal the composite number that's given to you. Notice here I used exponents, so it's 2 to the second power. I didn't write 2 times 2. I also wrote the 2 first and the 5 second because numerically, the 2 comes first and then the 5 comes second. So in numeric format, in order, the 2 should be first and then the 5 should be second as you're looking at that situation. Okay, when it comes to probability, there's a few ways that we can look at probability. The first thing is probability should always be between 0 and 1. The probability of 0 is something that's impossible to occur. The probability of 100% or 1 is certain to occur, and everything else is kind of in the middle. You probably have dealt with some of these words like likely, unlikely, certain, impossible before. Remember that those things are good to know, and then we want to start to relate those to actually numeric values. Okay, so things that are impossible to occur should be the lowest probability, which is 0. Things that are certain to occur, which is probability of 1 or 100%. And then equally likely would be a half or 50%. And then notice here that all of these have fractions, decimals, and percents. They're all used interchangeably as we look at these questions. For probability, the easiest way to find the probability of an event is to take how many outcomes work for your event divided by the total possibilities. We tend to go the fraction route just so we can see what we had for the number of favorable outcomes divided by the number of possible outcomes. And that's most likely the way you're going to be seeing a lot of probabilities as we look through this chapter. It is possible you could see decimals. It is possible you'll see percents from time to time. But in general, when we find probabilities ourselves, we're probably going to go fractions, and then don't forget to simplify. This is rolling a die or rolling a number cube. Remember, there's 6 sides to the number cube. So rolling an odd number would be 3 out of 6 because there's 3 odd numbers, the number 1, the number 3, and the number 5. And that's 3 of the 6 options, which notice I simplified down to 1/2. That would be an equally likely or unlikely choice. Rolling a 7 is impossible on a 6-sided die, and so that's 0 out of 6. That's impossible. And then rolling a number is a certain event, so that would be 6 out of 6, which is 1 for that situation. That would be something that would be certain. Now, what you don't want to get into in this question is, well, what if it lands on the corner, or what if it lands on the side or on the edge, and you have to re-roll it? Well, that doesn't count for your number, so it's a re-roll. So the die should always land on a number then as its final result. We also have what's known as a D20, a 20-sided die, also known as a icosahedron, as we kind of have looked at. Rolling an odd number should be 10 out of the 20 numbers, which is 1/2, which is a fair die should be half odd, half even. That's its normal setup. Rolling a 7 should be 1 out of 20, so this time it is possible to roll a 7. And rolling a number would be 20 out of 20, which is 100% or 1. In terms of dice rolling, you need to understand a 6-sided die, and you should understand also a 20-sided die, which is also called an icosahedron. There's also questions where you may have to predict what will happen based upon probability. So this says the probability of winning an event at an event is 0.13 or 13%. There's 500 people at the event. So if I want to figure out how many people we should expect to win, it's basically a percent times the whole. So it's 13% of this 500, so 0.13 times 500. Okay, so 0.13 times 500 would give me 65 people that should win. Notice here in this question, though, it says how many should we expect not to win. This is the typical switcheroo that math teachers like to pull on you. Okay, so don't forget that you have to take 500 minus the 65, which would be 300 or 435 that would not win. The other way that you could solve this question is if 0.13 or 13% would win. If we do 1 minus that, that would be 0.87 or 87% would not win. So I could also do the subtraction there. It's kind of like the discount versus amount paid situation. And that would be 0.87 or 87% of 500. And that would get me 435 as well. Either of these options work great in order to figure out how to find that answer. Next question we're going to look at is just dealing with rock, paper, scissors. This is the results when two people played. So you'll notice here I filled in all these numbers. The first step on a question like this is to figure out the total. So you'll notice here that I have a total of 40 because I just added up all these numbers. This question says find the probability both players picked rock. Well, that's only this one circled location of 8, so that would be 8 out of 40. And then don't forget to simplify, and that becomes 1/5. The next one says they tie, so that would be both rock, both paper, or both scissor. I just add up those three numbers. That would be 14 out of 40, which would be 7 out of 20. And again, I know the fraction may not be as easy to comprehend. A lot of times percents are easier because you can say, oh, that's not likely because it's less than half. You could always quickly check that with your calculator and divide it out to see what's unlikely or something. But when we're finding probabilities like this, we're looking for numeric answers, and we're probably looking for a fraction and then simplify, just so we can see where your numbers came from. Your homework today is kind of a lot of questions, but they should go fairly quickly because you're just doing some basic probability elements of them. So you got 1 through 3 and then 6 through 21 in section 10.2. Remember to simplify your fractions as you're looking at these probability questions if you're asked to find them. Also questions where you have to work backwards to figure out like how many you expect to win or don't win. It should just be a multiplication of the percentage or the probability times the amount of people, the total of the event. Or whatever you're dealing with for that situation. And that should help as you're going through your probability questions. Also make sure when they ask you to find the probability, you have numeric answers, not just likely, unlikely. Now there are some questions where maybe that's appropriate, but you also want to make sure that you're aware of questions where you have to put a numeric answer. Have a good day, everyone.